In this video, we will see how Gen AI developers and data scientists can easily deploy and use Nvidia's RAG application on infrastructure from various cloud providers such as AWS, Azure, GCP, and OCI. The Nvidia team develops and maintains various examples for showcasing how developers can implement RAG for Gen AI in this Git repo. These examples showcase how users can perform RAG efficiently, and these are heavily optimized by the Nvidia team to run on high-performance Nvidia CUDA software stack and Nvidia GPUs. The Rafay team has collaborated with Nvidia to develop a reference template based on Rafay Environment Manager for mutual users. With this template, developers and data scientists can deploy and experiment with the Linux-based RAG application in a single click on the top 4 public clouds, that is AWS, Azure, GCP, and OCI. Let's start by looking at the user experience for the developer or data scientist that wants to try this out. Once the developer logs into Rafay, they are presented with a catalog of environments that they can launch and experience. Let us search for the Nvidia RAG application. As you can see, the user is presented with 4 options and with each option optimized for one of the top 4 public clouds. For now, let's pick AWS and proceed. Let's review what and how the developer can customize with this environment. Clicking on the README provides a quick summary for the developer. In this example, the platform team has configured the template in a manner so that the developer has to provide some basic input and can perform overrides for some defaults. For example, they may wish to test the application on a specific instance type that has a certain type of Nvidia GPU. Clicking on the source code button takes the developer to the Git repository where they can optionally look at the infrastructure's code backing the environment template. Now let us provide some inputs and launch an environment on AWS. This whole process can take a few minutes to complete. Behind the scenes, the user-provided overrides are applied on top of the template to provision the environment. Let's follow the provisioning process. First, an Nvidia GPU-based EC2 instance is provisioned. Once this is successfully provisioned, a Llama-based LLM is downloaded from the provided URL and staged on the EC2 instance. Note that this is a very large multi-gigabyte file and can take a few minutes to download. Next, the Nvidia RAG application artifacts are downloaded from the NGX repository. Docker Compose is then used to dynamically build the required container images, and the RAG application is then deployed and made operational on the EC2 instance. All of this happens automatically with no involvement required by the developer or data scientist. As you can see, the environment has now been successfully created. Let's now figure out how the developer can access the application. Conveniently, Rafay provides a user with the exact URLs for this in the newly created environment. Let's copy the URL for the RAG application and access it using a web browser. The web application presents a Gen AI chat interface, and as you can see, is powered by a Llama 2 based LLM that we selected when we configured the environment. Let's test if the application works by asking it a simple question. And as you can see, it provides us a response instantly. Now let's perform RAG. Let's provide the LLM with new data by uploading a proprietary PDF from our database. The RAG application processes the uploaded PDF, creates embeddings, and stores these embeddings in a vector database. Now let's ask the Gen AI application a question which it can only answer based on insights from the PDF file that was uploaded. Notice that it was able to answer our question accurately. In summary, in this video, we saw how easy it was for a developer or data scientist to quickly configure and provision the Nvidia RAG application and the associated infrastructure using Rafay Environment Manager. We provisioned this on AWS, but the developer could have very easily also done the same on the other public clouds such as Azure, GCP, and OCI.